Hi all. So today we will be discussing a very important question format that has been repeated quite a few times in the ISI entrance exam. So these are kind of formats actually. You may get the same question or you may get a similar question of this type because we have seen both the types. They have repeated the same question and also they have given similar questions from this particular format. So let us see the question first. Using the question itself, we will understand the format of the questions. Okay, let's have a look at the first question. For the first time, this question was asked in ISI 2012. The question says, assume the following inequalities for positive integer k. So we have some sort of inequality for some positive integer k. We have to find the integer part of this summation, this sigma. So when this question was asked in 2012 for the first time, this inequality was given. We will also find out that the same question format was also repeated in the recent few years of ISI entrance exams. In 2020 and in 2024, they have given the same type of questions. Okay. Let us solve this question first because this question was kind of easier as compared to those questions because here the inequality was already given. Okay. So we have some sort of inequality. Basically, what we have to do, we have to take the help of this inequality to find out this integer part of this summation. This summation is going from 2 to 9,999 and 1 by square root of k is given. So once you open up this summation, we'll be having something like this: 1 by square root of 2 plus 1 by square root of 3 and so on and so forth. This goes up till 1 by square root of 9,999. Now with the help of this inequality, we will be finding the integer part of this thing. So what I do, I modify this inequality a bit. So basically we are having this, we multiply by 2 on all three sides. So we are having 1 upon square root of k plus 1 less than 2 times square root of k plus 1 minus square root of k less than 1 by square root of k. I'm multiplying 2 on all three sides. So we are having some sort of thing like this. I start putting the value of k is equal to 1. I put the value of k is equal to 1. Over here in this inequality, I put the value of k is equal to 1. So on the left hand side, I'll be getting 1 upon square root of k plus 1, which is 1 plus 1, 2, less than 2 times of root over of 2 minus root over of 1, less than 1 upon root over of 1. Similarly, I put the value of k is equal to 2. So I'll get 1 upon square root 3 times of 2 times the square root of 3 minus square root of 2 less than 1 upon square root of 2. And similarly, I put the value of k is equal to 3, 1 by square root of 4 less than 2 times of square root of 4 minus square root of 3 less than 1 upon square root of 3 and so on. So till where we have to take? The summation is going up till 9,999. So I'm taking up till 9,999. So put the value of k to be 9,999. So this will becomes 1 upon square root of 9,999 plus 1, which is 10,000 and less than 2 times of square root of 10,000 minus square root of 9,999 less than 1 upon square root of 9,999. Now you can clearly see that we have to add all of them. Okay. So on the left hand side, let us see once we add all of them, what are we getting on the left hand side? So on the left hand side, you can clearly see we'll be getting something like this: square root 2 plus square root 3 and so on till square root 9,999 plus square root of 10,000. Right? We'll be getting this thing. Now the thing is, this much portion, if you clearly see that this much portion, this is nothing but the summation which they have asked for. I mean, let us say if I take this summation to be S, so this is basically nothing but S only. So that's basically S plus 1 upon square root of 10,000, which is 1 upon 100. Okay. And let us see the simplifications on the left hand side. I mean, here, let's see the simplifications over here. Okay, so this, you can clearly see that a telescoping series is getting generated, right? That's the reason why they have given this particular summation, that some sort of telescoping series. You can clearly see if there is a difference of term, root over of k plus 1 and minus the square root of k. So definitely some sort of telescoping series will be generated when you take the summation. So here we are having square root of 2. Square root of 2 cancels out. Similarly, here root 3 and root 3 will cancel out. Similarly, this and this, the next term will cancel out, right? Similarly, this and this term will cancel out if you follow the format. So what is remaining? This term will be remaining and this term will be remaining, right? So here we will be having 2 times of square root of 10,000, which is 100, and minus of 1. So that's 100 minus 1 will be remaining. So 2 times of 100 minus 1 and less than. Similarly, on the right hand side, we will be having 1 upon root over of 1 plus 1 upon root over of 2 and so on till 1 upon root over of 9,999. Again, similarly, you can see that this much portion is nothing but the series given, series they have asked for. So that's S basically. So it's basically 1 plus S. So we are having finally, we can rewrite this inequality as S plus 1 upon 100 less than 2 times of 100 minus 1, which is 99. So 2 times of 99, which is 198, and less than, here we are having 1 plus S. So this is the series which we are having. So we need to find the valid range for S. So what are we getting from here? S will be lying in between. So from here, we will be getting S to be lying in between 197 and S is lying in between 198 minus 1 by 100. 198 minus 1 by 100. Okay, so clearly 198 minus 1 by 100 will be something less than 198. So that's 197 point something. So definitely this will be the integer part will be definitely 197. So integer part of this thing, integer part of S, that's what they have asked for. The integer part of S will be definitely 197. It's lying in between 197 and something less than 197, 197 point something. So obvious reasons, this will be integer part of this thing will be 197. So here again, I am saying in this particular question, this inequality was given. This inequality was given. But in the recent few years, if you see the question which was asked in the recent few years, you will see that this inequality was not given. They have directly given the series and they were asking for the integer part of the same. That is why you need to solve the PYQs in order to understand these questions. You need to solve the PYQs as much as possible, because these are those kind of questions. If you do not have the exposure to such questions, you will get stuck in the exam. Okay, so let us see some more questions of the same format. Again, you will see that the question was asked in ISI BITSAT 2020. So you'll see that the integer, they're directly asking for the same integers. The same question is given. Integer part of summation k is equal to 2 to 9,999 and 1 by square root of n is given over here, and they're asking for the integer part of this thing. So clearly answer will be 197. If you have solved the PYQs, so definitely answer will be 197. So there are two methods to do this thing. Suppose if you forget this inequality, that there is another way we can generate some sort of inequalities to solve this particular question. There is another way to solve this, but for which you need to learn how to generate this inequality. Again, I'm saying these are those kind of questions. If you do not have the exposure to such questions, you will get stuck in the exam, and you need to solve the PYQs as much as possible to understand these kind of questions. Like I said, so either you memorize this inequality which they have given, or what you can do is you can generate some sort of inequalities. So let us try to see this another way. Method number 2, how can we solve this using the second method? So what I'm doing is I'm trying to generate some sort of inequality over here. So we know root over of n is there. Okay. So root over of n lies in between root over of n minus 1 and root over of n plus 1. This is quite obvious inequality. So what I do is I'll simply add by root over of n on both the sides. I'll simply add by root over of n on both the sides. So this becomes root over of n plus root over of n minus 1 and less than root over of n plus root over of n, which is 2 times root over of n, and less than root over of n plus root over of n plus 1. Fine. I'm simply adding by root over of n on both the sides. Now I need the reciprocal of this thing. So I'm taking reciprocal over here. So this becomes, you will see that once I take this reciprocal over here, so you will see that this orientation of this inequality will simply change. And finally, we will be having 1 by root over of n plus 1 plus root over of n less than 1 by 2 times of root over of n less than 1 upon root over of n plus root over of n minus 1. So this orientation of this inequality will change because you're taking the reciprocal. This less than will become greater than sign, and we are simply reversing this inequality. Next, what I do, I rationalize this thing so that we can get some sort of difference format. So I hope you're getting what I'm trying to do over here, because I'm trying to generate some sort of difference over here. We will be rationalizing this thing because we need to generate some sort of difference. Why? Just to bring into the telescoping series format. So we are having 1 by square root of n plus 1 plus square root of n. So what I do is simply rationalize this thing. So once you rationalize, we will be having root over of n plus 1 minus of root over of n in the numerator divided by, and in the denominator we will be having root over of n plus 1 whole square minus of root over of n ka whole square, which is simply 1 itself, less than 1 by 2 times the root over of n. And same thing goes for here. So we will be rationalizing this thing. So this becomes root over of n minus of root over of n minus 1. And in the denominator, we will be having 1. So now you can clearly see that we are having some sort of difference over here. This is some sort of difference. Again, we are having some sort of consecutive difference, more specifically consecutive difference. So there are chances of generating telescoping series. So I keep on putting the values over here. You put the value of n to be 1, then n to be 2, and so on. We can generate all sort of inequalities from here itself. So now we are having 1 by square root of 2 times of square root of n over here, right? So here we have to start the summation from 2 because k is starting from 2, or not k, basically this will be n. So n is starting from 2. So we have to start this inequality, this summation from 2 itself. So I start putting the value of n to be 2, and we'll get a series of inequalities over here. We'll simply add them. Okay, we'll simply add them and we'll try to get some telescoping series over here. So I put the value of n to be 2. So this becomes square root of 3 minus square root of 2 less than 1 by 2 root 2 less than. This becomes root over of 2 minus 2 minus 1. This is 1. Put the value of n to be 3. So this becomes root over of 4 minus root over of 3 less than 2 times root over of 3 less than root 3 minus root over of 2, and so on and so forth. Put the value of, let's write some of them, and then we'll generalize, and this continues. So till where we'll take it till n is equal to 9,999, so that this becomes square root of, finally this will become square root of 10,000 minus square root of 9,999 and less than 1 upon 2 times of root over of 9,999 and less than square root of 9,999 minus square root of 9,998. Okay, since there is lack of space over here, I'm writing it over here itself. So we are having some sort of series of this type. So we'll add up all these series. On the left hand side, we can clearly see there are some sort of cancellations. We can clearly see, right? These terms are getting cancelled. Root over of 3 and root over of 3 will cancel out. Root over of 4, root over of 4 will cancel out, and so on and so forth. So this term and the next term will be cancelled out, right? So similarly, this term will cancel out just like the previous one. So we are having some sort of telescoping series. So this term will be remaining and this term will be remaining. So that's basically root over of 10,000, which is 100, right? So 100 minus root 2, right? 100 minus root 2 less than half times of, half is getting common over here. What are we having? We can take out half common, and then we are having 1 by root 2 plus 1 by root 3 plus 1 by root 4 and so on till 1 by root over of 9,999, which is the required series given. And so we can write this as s itself. We can take this to be some s or something. So half times of s is less than. Similarly, root over of, we'll get cancellations here. Root 2 cancels out, root 3 cancels out. Similarly, these terms will cancel out. Okay, so what is remaining over here? Here, this will cancel out. So 9,999 minus of root over of 1. Square root 9,999 minus root over of 1, which is 1 only. Okay, and we can get rid of this 2 by multiplying 2 on all three sides. We can get rid of this 2 by multiplying all three sides. So we'll get the direct values of s over here. We get rid of this 2 by multiplying 2 on all three sides. So we are having this thing. So now we have to calculate this range over here. So this is easy. So 100 minus root of 2. So approximately this will be somewhere around 197.17. Okay. This quantity will be approximately 197.17. And similarly, this quantity will be 197 point something, 197.9 something, 97, most probably. So 197.97. So once you calculate this thing, so your S is lying in between this quantity. So clearly, again, so the integer part of this thing will be clearly 197. Integer part of this thing will be clearly 197. So this is another way of solving this question. So here what we are doing, here we are generating this inequality using this simple thing. Using this simple basic inequality, we are generating this inequality and we are using telescoping series over here. Okay. So here the main thing is this inequality. This is the main inequality. So likewise, I said, either you remember, either you memorize this inequality, which they have already given in ISI 2012, or you can simply use this basic inequality to solve this question and you will end up getting the same answer. So let's see one more question. Now look at this question. So this was asked in ISI 2024. Recently, they've asked this question. So S is given to be the series. Okay, so likewise here, they haven't given the series format in summation format. So they have given a series format over here. Okay, so again, here we have to find the largest positive integer not exceeding S. Okay, so we have to find the integral part of this thing. Again, the logic remains the same. We have to solve this using the same inequality. But we have to first see over here, we are having some sort of series which starts from 10,000. If you express this thing in terms of summation, this starts from 10,000. Okay, the summation is kind of starting from 10,000. This is actually summation. If I write this in the summation format, this is summation, let's say n is going from 10,000 to 1,60,000. 10,000 to 1,60,000, 1 by square root of n is there. This is what we are having. So can we directly jump to the conclusion? Just now we have done all sort of calculations over here. Like we have derived this inequality. We have to do the same thing. We have to do the same thing. Square root of n lies in between root over of n minus 1 and root over of square root of n plus 1. Okay, then you have to simplify, add root over of n on all three sides, and then we have to rationalize, right? So you will be getting this thing only. You will be getting this inequality only. Okay, so since we have already done this thing, we can take the help of this thing. So square root of n plus 1, we are having square root of n plus 1 minus of square root of n less than 1 by 2 times of root over of n. So we can multiply this 2 over here directly, less than root over of n minus root over of n minus 1. 2 times root over of n minus root over of n minus 1. You have to multiply by 2. So directly I'm in this step only, I'm multiplying by 2 over here. This remains the same thing. Okay. And then we'll take the summation over here. Summation goes from where? Summation starts from 10,000. So we'll take the summation from 10,000 to 1,60,000. And that's all. We'll simply try to modify this thing. Okay. Again, all sort of telescoping series will be there. And we will solve this thing. So once you take the summation over here, so this will become 2 times. 2 is just a constant, so we can simply keep this outside. So summation goes from n is equal to 10,000 to 1,60,000, right? Root over of n plus 1 minus root over of n less than, similarly, summation n is equal to 10,000 to 1,60,000, 1 by square root of n less than 2 times of summation n is equal to 10,000 to 1,60,000, and this is square root n minus of square root of n minus 1. That's what we are having. So now you have this basic idea that what will happen in this summation. You start putting the values of n, right? you need not write so much of things. You can directly now see. You have solved telescoping series. If you have solved telescoping series, if you have learned telescoping series, you will get to know what is the pattern over here. Obviously, the first term is what, 10,000. Put the value of n to be 10,000. This will become 10,000 plus 1. So that's basically 10,001, right? 10,001 and so on and so forth. Likewise, minus of root over of 10,000 and all sort of things. So we have solved a similar problem last time. Yeah, so you can clearly see, right? The first term, this term will get cancelled. This term and this term will get cancelled. So what is remaining? What is remaining in both the cases? The last term is remaining, right? The second last term rather. The second last term is remaining and the second term is remaining from the beginning, isn't it? The second last term and the second term is remaining. So we'll have the same thing over here. The second last term is what? Second last term will be, once you put the value of the final value will be what? 1,60,000, right? 1,60,000 and 1,60,000 plus 1 will be 1,61,000, right? 1,60,001 and minus square root of the second term is what? Second term is, put the value of n to be 10,000. So this will become square root of 10,000, which is 100. So what is remaining? What will be remaining? So 2 times of square root of 1,60,001, right? And minus of square root of 10,000, right? So I'm directly writing this to be 100. Are you getting my point? What I'm trying to say? Basically, the second last term and the second term, the second last term and the second term from the beginning will be remaining. The same thing goes for this series as well. I mean, that's what we have seen, right? And this is the required series S less than 2 times of. Similarly, the second term and the second last term. So 2 times of what will be remaining? 2 times the square root of, what is the second term? So square root of 400. Square root of 400 will be remaining. Square root of 16 lakh, 1,60,000, which is 400, and minus of square root of 9,999 will be remaining. These terms will be remaining. So now you can clearly see from here. Now 1,60,000, 1,60,000 is, the square root of 1,60,000 is basically 400. So this is approximately 400 point something. So 400.001 and minus of 100. So 2 times of 400.001 minus of 100 and less than S less than. Similarly, this is approximately square root of 9,999, which is 99.99 something. Okay, so approximately again, this will be 2 times of 400 minus 99.99. This is approximately somewhere around 300.01. And then next we have to just simplify this thing. So again, so we are having 400.001 minus of 100 and then multiplied by 2. This will be close approximately around 600.003. This quantity will somewhere lie in between 600.003 and 600.01. Again, the largest positive integer not exceeding S is definitely 600. This S is lying in between this range. So definitely the integral part of this thing will be 600. Option C will be correct. Okay, so you can see what is the importance of this format. The first time they have asked this question in 2012, where they have given that inequality. So either you memorize this inequality or you have to proceed using this thing. Basically, root over of n lies in between root over of n minus 1 and root over of n plus 1. Okay, so you need to solve, like I said, you need to solve the PYQs to have an exposure to such kind of questions. Okay, so these are those kind of questions. If you don't have this exposure, you'll get stuck in the exam. So keep on solving the PYQs.